Oh, hello students. In Module 1, 2, and 3, we went a little bit slow and we covered things several times because we wanted to make sure that you knew how to identify variables and that you were comfortable doing calculations with Python and understanding lists and all different elements such as floats, integers, and other things. On Module 4, we're moving into what are lists and working with lists. So what is a list? A Python list is a variable that can store multiple items. We already seen some examples. As you can see here, we have the variable squares, and it is assigned a list with different elements. The elements in this case are numbers, but truly lists could have any element inside of the square brackets. Remember that lists are always data stored in a square brackets. A list is always initialized by assigning values as a comma separated list between square brackets. So if you had squares assigned to parentheses 1, 4, 9, 16, 25 parentheses, that would not be a list. Remember, lists always have square brackets. The data is stored sequentially in list elements that are index number starting at 0. I know it is strange, but it helps me to remember, like when I travel to Europe, for example, and I got and hop into an elevator, they always have the bottom floor at 0. Just remember that. Even though element 1, 4, 9, 16, and 25 on this list, each one has what is called an index. The first element, which is the number 1, will be at index 0, not 1. For example, we have a list containing the height in meters of a Victoria's Secret model. Victoria's height of the models are 1.92, 1.77, 1.82, 1.86, and 1.99. My question to you is this. Which element in the list, what is the index of the element in the list 1.86? Can you guess? Remember, we're starting at 0. So 1.92 will have index 0, 1.77 will have index 1, 1.82 will have index 2, and 1.86 is index 4. So the answer will be index 4. Like strings and all other building sequence type lists can be indexed and sliced. As you can see here, they are trying to find out the index in number or index 0. That was 1. Remember our list from before? You can also reference the list by starting from the last element. So if we go back to the list that we have in this example over here, our last element is 25. You can also begin a list by counting from here. So 25 in this case will be minus 1. Minus 2 will be 16. Minus 3 will be 9. Minus 4 will be 4. And minus 5 will be 1. Let's go back to our squares. So squares minus 1 is element 25. If we go to squares minus 3, we get 9. You can also slice a new list. That means slicing means that you're going to cut a list. And you're going to tell the function squares or the list squares from which element to which element you want to slice or cut the function or the list. All slice operations return a new list containing the requested elements. This means that the following slide returns a new shallow copy of the list. In this case, squares, we want minus 3 to the beginning. minus 3 to the beginning from the original list will give us a new list with the elements 9, 16, and 25. Let's see if that's true. If we go to our example here, they told us from minus 3. So we came from the back, minus 1, minus 2, and minus 3. Minus 3 to the end will be the elements 9, 16, and 25, but this will be a new list. In this example, in which squares, you have seen that if we have semicolon, the semicolon means that we want all the elements from the beginning to the end. All the elements from beginning to end will give us a new list, which seems unchanged. 1, 4, 9, 16, and 25. Lists also support operations called concatenations, which we know is addition. If you wanted to add the list squares to a new list with all these new elements, as you can see, you will get a brand new list with the elements from the list square plus the new list. One good thing will be to try this in idle, so please feel free to try these exercises in idle as we go along. The only way to retain some of this information is by you doing it on idle. A list is a list of items, nothing else. It is useful to create a list when you're working with many data points or huge amounts of information instead of creating many variables. List is a way to give a single name a collection of values. A list can also have lists inside of them, like we saw when we were looking at concatenation. Python knows the number of compound data types used to group together other values. The most versatile is the list, which can be written as a list of comma-separated values or items between square brackets. Lists might contain items of different types, but usually the items all have the same type. One example that comes to mind is, for example, let's say a data analyst wanted to work collecting lists or data from baseball players. He might have several lists. One list containing the name of the player, another one the height or the weight of the player, and another one the batting average. If the programmer had to create variables for each one of them, it would be extremely difficult. But by making all this into a list, he will be able to filter data faster and create data knowing who's the baseball player that has the better batting average, or what players are in the same height or weight range. Does that make sense? I hope it does. As you can see, we're going to try to repeat information. List is the most versatile data type available in Python. Right now, we're working in what is called a one dimension. Lists are useful in mathematics, and when you study intermediate Python or advanced Python, you will see that lists are used in matrices. We use lists and matrices in mathematics to be able to analyze data in more than one dimension. Creating a list is as simple as putting different comma-separated values between square brackets. These are all types of lists. As you can see, some lists have strings. A list can have different types, such as list 1, in which we have physics and chemistry, which are strings, and also has values like 1997 or 2000. List 2 contains integers numbers, but you can also have a combination of integers, floats, and strings. And finally, list 3 are all strings. Like string indices, list indices start at 0, and lists can be sliced or concatenated. Of course, we can do all kinds of things with lists. In the next video, we will talk about mutability of the list. That means we can change lists. As we saw, we can already addition, dice, list. So you'll see in the next method and lecture how we can change their content, how can we delete content or insert content on a list. I hope that you stick around. I'll see you in the next lecture.